Hey everybody, Jeff Simon here with another cool building stage on our Titan T-51D Mustang. I'm here with Lithra here, back here with us for winter break from mechanical engineering over at the University of Massachusetts Amherst. And we are getting so much done. I love it. We're just plowing through this build. And one of the things that we, of course, need to do, and is a big priority of ours, is to do everything we can in the cockpit all the way through to the firewall so that we can close this up, put the canopy, build the canopy on it, the mechanism, and then we can finally close the rest of the fuselage up and move it out. So let's talk a little bit about what we're going to do today. Today we're going to work on control cables. Lithra, if you want to kind of show those. So we have these really high quality, wonderful control cables from McFarlane Aviation. And what's nice about working with a company like McFarlane is that you can really tell them what your problem is and they help you solve it. And in our case, we have a lot of unknowns. We didn't know exactly where we're going to be passing through bulkheads, and I didn't want to measure something. It's not like we're taking out from a certified aircraft an existing cable and saying, duplicate this. And so one of the things that they did, in addition to providing these, again, very high quality Teleflex style cables, is they put on these pass-throughs with a whole bunch of different nuts and a threaded ferrule that is normally crimped to the shielding, but in our case the outer layer, and in our case it's not crimped, so we can move it wherever we need to, put it through a bulkhead, and it becomes our pass-through. So that's going to be really cool because that'll give us a ton of flexibility. Now, one of the other challenges that we have to do here is how we are going to attach the prop cable and the throttle cable to our prop and throttle controls in the cabin. Now, those prop and throttle controls already have rods going for the pilot and the passenger in the back that keep them in sync back and forth. And we need then to go forward from that point. Now, in one case, on the throttle control, the arm actually is such a way that there's a second hole, so we can actually attach there and move forward. But in the case of the prop control, we have a challenge, and that is, what do you do when you have a rod end and then you need to go forward from that rod end? You can, if you have room, you can piggyback them, you can put two rod ends together, you can make bell cranks, so there's all sorts of options. But Titan came up with something that I think is pretty cool design. They created this little small steel U, and what basically happens is, if this is the rod end that's inside going from the front to the rear control, this piece comes and sandwiches around it and then gives you a hole that you can then mount the cable to. Because our cable ends are 1032 size screw ends, male ends, and we can put something through there and then move forward from that point. So kind of a cool, innovative solution to doing that. So Lithra, what are your thoughts on kind of how you're going to approach this? Because there's a lot of variables.
So in addition to that, we have to figure out how to attach it to the wall itself. The side wall of the cockpit. So I think I'm first gonna mount these onto the quadrant and then figure out how it routes through the cabin and stuff, and then figure out a place to put that piece of aluminum to attach it to the wall. And then go on from there, I guess. I mean, you got to come up with a mounting bracket, and we don't know where it's going to lay, whether you're going to be vertical or horizontal or staggered. You got your work cut out for you with this one. We already figured out the holes kind of on the firewall and the wall behind the firewall. So I think that's pretty much set. At
least we know what we're controlling on the engine, and we were able to then measure and get the cables from McFarlane from that. So. Well, it's a cool challenge. Looking forward to tackling it. Excellent. All right. Well, we're going to get to work and get us a little closer in our Titan T-51D build Mustang. Let's go. Let's talk about parts quality. Now, when you're building an experimental aircraft, you have a lot of flexibility. You can get parts from your local hardware store. You can get parts from Walmart. You can get parts from anywhere that you want. But that doesn't mean that you necessarily should. And this is a perfect example of that. We went and purchased just some rod ends off of Amazon from a few different manufacturers there, and then compared them to what we got from McFarlane. And the results were really surprising. When we look at the McFarlane part, the rod end, first of all, it's traceable, it's marked, it says it's made in the USA with a part number. You can tell it's a very, very well-made part, and the ball is easy to turn but doesn't have play, doesn't have anything that really matters. It's a really well-machined component. And this is important because it's going to be subject to a lot of vibration on the engine, and also, of course, it's your connection from the cockpit. We're using these at both ends of the cable over there. Now, this is a less expensive one that we found over on Amazon. We tried again a couple different parts, and this one's got a little bit of play in it, and you can tell it's much more roughly produced on it. A lot of tooling marks that are on that. Not too bad, but a little bit sticky on that. And then this third one that really looked good online has a nicely machined surface on one side, a little bit rough on the sides, but ultimately the ball itself doesn't feel like it's manufactured in a way that's going to survive. You can tell the way it's produced that it looks like it's all kind of one piece in the way it's been milled, whereas or manufactured, whereas when you look at this one, you can see that there's actually a pressed in component and it's made up of multiple pieces. So just something to consider there when you're looking at parts and thinking about parts quality, because again, even though you have flexibility on a experimental aircraft, doesn't mean that you shouldn't exercise good judgment to where high quality parts need to be used. Now, here are the two different examples of how we have to handle the rod ends. The first one here is when we have an open hole, we can use a rod end and go directly on the 1032 threads that are there. Perfect, simple way of handling it. In this case, when we already have a rod end and we don't have another hole on the lever, we actually use the little piece that was made by Titan and engineered so that you can kind of go as a doubler from the rod end forward in this case. And again, that's because we already have this rod end that's going aft to the aft controls, and it works pretty well. Now, Lithra, when we were talking about this part and how Titan designed this so that you could kind of go from a rod end forward, you had a really good idea and a very valid question. And that was about, why are we using this? Yep. What is it that you found online that we could have used?
So after doing some research, I found a double female rod end.
Yeah. So like this with arms on both sides of it. Yep. It looks like a kind of a propeller in it with a hole in the center.
Yep.
And for a little bit we thought that would probably be a good solution, but then we realized kind of the genius of why Titan made this very simple part versus getting a double rod end. Yep. Do you want to explain why?
Yeah, due to the motion of the prop handle, it keeps the rod end parallel, but it moves up and down.
Right, so it follows the arc of the actual control. You can actually see kind of simulated right here what it does. It kind of goes down a little bit and up a little bit, but it always stays perfectly level because it's attached to a rod that's going to the back control as well. And that gives us a complication. You want to explain that?
Yeah, so since it moves back and goes up and down, the double rod end doesn't, so since it goes up and down, the double rod end doesn't,
can't move, it can't flex.
Move, exactly. Right? So the Titan part actually allows it to sort of pivot inside. And allow it to go up and down.
I think that the challenge is when we look at a typical cable rod end like this, they have flexibility, but the way they have flexibility, this one's still got the shipping attachment to protect it on there, but the way that they have flexibility is they can have this flexible joint where they can go a little bit up and a little bit down. But what they can't do in the way that they're going to get mounted is they can't move down and up, because ultimately this portion here is going to be fixed to the sidewall and be fixed in one location. So we can have some flexibility, but we can't rotate up and down. And so with this, it allows that flexibility because this will be a hinge point where we go through. And so realistically, as that moves down, I'm exaggerating it, but this can rotate up and down. And if we had it fixed all the way, it'd just be jammed.
Exactly.
Yeah.
Yep.
Well, there's some genius in the details from Titan, and I'm glad that we figured that out. Sometimes you look at something and you think, oh, there's got to be a better solution. Nope. That was a great solution. So kudos to them. All right, let's get together with the rest of the build.
Okay, so I just finished making the bracket for the throttle and prop cables in the cabin end, and as you can see, the holes are a bit offset. That is because we had to make modifications on our throttle and prop quadrant to give the throttle more throw, and this actually ended up with the tie rod ends actually hitting at the end. So we had to bend the prop lever out a little bit, and that is why the holes are staggered. But moving on to the next step, we're going to be drilling holes on station number 3 and station number 2 to feed our ferrules through. And the good thing about these ferrules are it actually gives you a little bit of leeway where you can move it back and forth, so you don't have to be exactly precise with your measurements. Where it took me a long time to get these measurements precise, but then we actually found out that you don't need to be that precise because you have a lot of play with the movement of the cable, because you can adjust it with the rod end at the end, and then you can also adjust it with the ferrules on the cable. The good thing about this cable is also, since it's swivel type, when you're actually mounting it onto the throttle and prop quadrant, you actually have to go up a little bit. So these cables allow you to go up and meet that requirement, which is great. But moving on to the next step, I'll be drilling these holes on these firewalls and then mounting the cables in.
All right, that was one of the coolest stages of building, because anytime that you can move a control and it does something, it just gets me all excited. Yeah. And special thanks to McFarlane Aviation. They are a strong supporter of SocialFlight, and they supply these amazing cables. If you need cables for your aircraft, be sure to check them out, as opposed to just OEM stock or any other kind of cables. Having them be Teflon lined, custom designed, everything was just perfect.
Yep.
We designed exactly what we needed with every measurement, and they just made it.
Yep.
And then they showed up, and some of the things were very custom, like putting extra ferrules on that let us pass through different bulkheads and make it all just work. But here we are with a finished product, and now you can move your prop control, you can move your throttle, and so I just want to say there were a lot of problems to solve to make this happen and clear everything. Nice job. Really. You did a fantastic job. You can tell he's a mechanical engineer because he knows how to solve all these things. So until next time, I'm Jeff Simon for SocialFlight. Be sure to check out socialflight.com and the free apps for Apple and Android devices. Just search for one word, SocialFlight. We have tens of thousands of aviation events, destinations, cool things. We have our Fly to Win challenge, where you can go and get points by flying to airports and win prizes. And of course, every Tuesday evening, we have SocialFlight Live with fantastic guests, famous people from aviation. It's a ton of fun. I've made so many friends through that show. Just go to socialflightlive.com to register. Until next time, I'm Jeff Simon for SocialFlight. Blue skies.